Alright, so then let's do one more little example here. Let's look at r is equal to negative 5r plus 18. And let's just kind of go through our steps here. So again, we need to collect the variable terms on one side and the constant terms on the other side. Well, I need to move these 5r's to the other side. I'm going to use inverse operations to do that. So let's add 5r to both sides plus 5r. And then simplifying on the left side of the equation, 1r plus 5r's, that's going to leave me with 6r. And on the other side of my equal sign, negative 5r and positive 5r, well, that's going to zero out and be nothing. It's going to leave me with this 18. 6r is equal to 18. And now at this point, it's just like any other equation that we've been working on. To get r by itself, I need to use the inverse of division or of multiplication. I need to divide both sides by 6, and we get r is equal to 3. r is equal to 3. Now, 1.3 is different from the other ones, and here's where you might want to tune in. There's special cases. 1.3, we have these special cases. So let's write this, and I'm even going to do it here in all caps. Special cases. Special cases. Here's one example of a special case. Let's say you have the equation 2x plus 10 is equal to 2x. And I'm asked to solve for x. Well, I know, because I've done this a lot, I've gotten pretty good at looking at equations and telling that they're special cases. And I'll go ahead and just give you the spoiler right off the bat. If you ever notice that the variable term is exactly the same on both sides, you know it's a special case. Keep that in mind. Okay, so let's pretend I'm trying to solve this thing. You're probably thinking, hey, I need to move the variable terms all to one side, so let's get rid of them here. Let's subtract these two x's from both sides. Two x and minus 2x, that's going to zero out and leave me just with 10, with the plain or constant number 10. And then on the other side, minus 2x or minus 2x, positive 2x also zeroes out, but there's no other term here, so I'm left with just 0. Now what do I do? What does x equal? What is it? It's not 1. It turns out, hey, in this case, x is gone. This is an example of no solution. This is no solution. And here's why. Okay, this math is lying to you. This is what sometimes I call it a fake equation. This math is lying to you. This is not true. That means there is no value of x that makes this equation work. It doesn't work. It's a broken equation. Broken. That's a special case. If the x variable gets completely eliminated and you're left with something that's lying to you, then we say that's no solution. Doesn't work. What's up?
So if we have this on big ideas, would we just put 0?
No, because 0 could potentially be a solution. In fact, 0 is a solution to a lot of equations. So you say exactly this, no solution. You say no solution, that's the answer. Here's your other special case. Let's look at this example. 2 times the quantity, x plus 3. Good question. Is equal to 2x plus 6. Okay, in this example, I'll go a little bit more quickly here. I'm going to start by distributing. 2 times x is 2x. So I'm simplifying this expression. 2 times 3 is 6. And on the other side, I still have 2x plus 6. Now, some of you might be noticing something already, but I'm going to keep going. Got a variable on both sides. I need to try to move all the variable terms to one side. So let's subtract this 2x. What I do to one side, I have to do to the other. going to zero out on this side. I'm left with 6. And then it turns out it's going to zero out on this side as well and leave me with 6 again. 6 is equal to 6. What happened to our x variable? What happened to our variable? It's gone again. It got eliminated. Now, is this true? Is 6 equal to 6? Okay, so what does x equal? It's not 6. It doesn't equal 6. It turns out, hey, if you eliminate the x variable and you're left with a true statement, then that means that there are infinitely many solutions. Infinitely many solutions. Infinitely many solutions. And that means no matter what x is, the equation's going to work. This equation will always work. You can pick any value of x. You could pick 10, you could pick 100, you could pick pi, you could pick negative 14. You could pick any number you want, and this equation will work. So x has, there are infinitely many solutions to this equation. So I'll just go ahead and say this again, because here's your trick to identifying a special case. If you ever notice that the variable term is the same on both sides, in this case, I had to distribute before I noticed that. But if you ever notice that, it's a special case. It's either no solution, meaning it's a fake equation, it's lying to you, or it's a true statement that means there's infinitely many solutions. All right, let's play a fun little game now.